Today we're going to continue building on what we've been working on this unit. We're going to work on solving equations with variables on both sides. So in order to solve these equations, the first thing we do is distribute. Then we combine our like terms. That should sound familiar to us. We talked about that under multi-step equations. Then we're going to move our variables to one side. I would recommend moving them to the left. And move our constants, our numbers, to the other side. And then we're going to solve for the variable. There are some special examples that we're going to talk about. Some equations have no values of the variable that would make the equation a true statement. That equation would have no solution. So when you're solving these equations, if at the end you get something that looks like this, does 5 equal 0? Is that a true statement? No. So you would write that this example has no solution. There are also equations that are true for all values of the variable. That equation has infinite solutions. So for example, at the end of your problem, if you're left with something like this, 6 equals 6, is that true? Yes, 6 equals 6. So you need to write the words infinite solutions. We're going to do a couple examples together. Looking at example 1, the first thing we need to do is distribute. Is there anything to distribute? No. Combine like terms. When we talk about combining like terms, remember they have to be on the same side in order for us to do that. So there aren't any like terms on the left, and there aren't any like terms on the right, so we can move to step 3, move our variables to one side. In order to do that, remember we have to think about the opposite operation. Right now I have a positive 7. So to undo that, I'm going to subtract 7x. Do it from both sides. 4x minus 7x is negative 3x. That minus 9 stays over here. And if these 7's go away, what else is left over here? Just that 12. Now if you think back to those do and undo tables, what's the first thing we need to do in order to solve for x? We need to add 9 to both sides. Again, my 9's cancel each other out, which leaves me with negative 3x equals 21. Now I just have one more step to do. In order to solve for x, I have to divide by a negative 3. So x equals 21 divided by negative 3 is negative 7. Looking at example 2, is there anything we need to distribute? No. Is there anything on the left that we can combine? Nope, there aren't any like terms. Is there anything on the right we can combine? Nope, no like terms over there either. So we're going to go ahead and move our variables. I'm going to subtract 6y from this side. Remember, we're going to now combine these terms. They both have a y with them, so I'm putting them together. 6y minus 6y, well those cancel out. They've canceled out from this side, so what's left? Well, on the left-hand side I have negative 3 equals what? What else is left over there? We have an 8. Does negative 3 equal 8? No. So this is not true, which means we have no solution. Okay, and there are a few other ways to write that. If you think back, we've learned this. You can have empty braces. You could see the words null set or empty set. All of those things mean no solution. So if you ever see any of those options for no solution, that's what those mean. Looking at example 3, we have a proportion. Remember, to solve proportions, we cross multiply. So I have 5n and 2 go together. And then on my other side, I have 1 times 5n plus 10. So 2 times 5n equals 5n plus 10 times 1 would give me 5n plus 10. Anything times 1 is itself. So now I can go ahead and distribute 2 times 5n, multiply, I guess, 10n. I don't have anything on the left I can combine. My right hand side I can't combine anything, so I can go ahead and move my variable. Subtract 5n, which cancels these out, and leaves me with 5n equals 10. Now I'm at the last step. How do I get n by itself? Divide by 5 on both sides, so n equals 2. Moving on to example 4. All right, so here we have a problem. Again, the first thing we always do is distribute. What am I distributing in this problem? There's actually 2 numbers that I need to distribute. So on the left-hand side, I'm distributing this negative 5. So I have 8p, negative 5 times p, minus 5p, negative 5 times 3, negative 15. And then if we look on the right-hand side, there's a 3 after that parentheses, so that gets distributed. 3 times 7p is 21p. 3 times negative 1 is negative 3. Now I can go ahead and combine my like terms. So looking at the left-hand side of my equation, 8p minus 5p, 3p. Since they're on the same side of the equation, we just follow the operations that are there. We're not adding 5p to both sides or anything. We're just saying 8p minus 5p. All right, now I'm going to move my variables to the left, so subtract 21p. 3 minus 21 gets me a negative 18p. And I move my constants to the right, add 15 to both sides. Just going to cancel these 15s out. Leaves me with negative 18p equals 12. How do I get p by itself? Divide by a negative 18. So p equals negative 12 over 18. What number goes into 12 and 18? We can divide both of those numbers by 6. So my answer, p equals negative 2 over 3. Remember, you can check that in your calculator. If you click negative 12 divided by 18, then click math, enter, enter, it will give you the fraction in simplest form. Just because we got a fraction, does that mean our answer is wrong? No, there are times when we will get fractions. How can we make sure that our answer is correct? Well, we can go back and plug that p in everywhere it says p and see if we get a true statement. All right, so moving on to number 5, we need to first translate this. 2/3 of a number reduced by 11 is equal to 4 more than the number. So I have 2/3 of a number reduced by 11. So reduced by means subtraction is equal to 4 more than a number. So I'm starting with the number, x, and adding 4 to it. I need to move my variables to the same side, so I'm going to subtract x from both sides. What's in front of this x? What number? If you want to, you can go ahead and write a 1 in front of it. 2/3 minus 1 gives me what? Negative 1/3 x. Now we're down to a 2-step equation. So I'm going to add 11 to both sides. Cancel these out. Negative 1/3 x equals 15. All right, last question here is how do we get rid of that fraction? What do we need to do in order to get rid of that fraction so that x is the only thing that's left on the left-hand side? We multiply by the reciprocal. So the reciprocal of negative 1/3 is negative 3. So we multiply by negative 3. Just going to cancel these out and leaves me with x equals negative 45. Again, you can always go back and check your answer. If we plug this into this x and that x, we should get a true statement. We'll get a number equals itself. And the last problem we have to talk about is number 6. Number 6 is a similar start to number 3. We have a proportion here. So, excuse me, we cross multiply. So I have 2 times 3x plus 9 is equal to 3 times 2x plus 6. It's on the right-hand side. Again, I have 2 places to distribute here. I have this 2. 2 times 3x is 6x plus 18 equals, and then I need to distribute this 3. 6x plus 18. Do I have anything on the left-hand side I can combine? Nope. Anything on the right-hand side? Nope. So we are good to move our variables. I'm going to subtract 6x from both sides. 6x minus 6x, well, that cancels out. And 6x minus 6x also cancels. So what's left over here? 18 equals 18. Is that a true statement? Does 18 equal 18? Yes, this is true. So in this example, we have infinite solutions. Again, there are a few other ways to write this. We could write all real numbers. We could see this R. Or you could see negative infinity to infinity. So any of those options mean all real numbers are infinite solutions. Any number I plug into this equation would make it true. Those are all of our we do examples, so if you don't have any questions, you can go ahead and start your you do's. Once you're done, please raise your hand and one of us will come around to check you.